So this problem is asking for the zeros of this polynomial. And this polynomial is not in factored form. Ah, shoot! We need it to be in factored form in order to find all the zeros. So the first thing we're going to have to do is we're going to have to factor this. So when you factor, make sure you always check for the greatest common factor first. The greatest common factor for that polynomial expression is 3x. Oh man, you guys are good. That means I can divide. That's the biggest number I can divide each of those terms by. And when I divide each of those terms by 3x, this is what I get. I get x squared minus x minus 6. Now this isn't technically a factoring lesson, but let's keep going on that. What do you have to multiply? What two numbers can you multiply to give you negative 6 and then add to give you negative 1? Yeah, negative 3 and positive 2. And so I can finish my factoring business. Boom! Now I take each of these factors and I set them equal to 0. That's how I'm going to find the zeros. So what do I have to do for the first one?
Wait, slow down.
Okay, now remember guys, these are single, like one-step equations.
Yeah, I get what you're doing, but God, dang it.
Yeah, I know, I went really fast. I wrote each of these factors and
I see what you're doing.
Okay, so tell me what I would get for this x. 3 times what gives me 0? Yeah, or I can divide both sides by 3 and I would get 0. You do the inverse operation thing. Okay, and then this one would be a 3 because 3 minus 3 is 0, so you get x equals 3. And then this one would be a negative 2 because negative 2 plus 2 would equal 0. Booyah. Booyah, right? And so those are going to be your x-intercepts. You just graph them and you're diggity done. Okay, I want to talk about zeros just a little bit more, okay? Whenever a problem says, like, find the zeros or whatever, you're essentially looking for the x when you plug into this function, you would get 0. Okay, because wherever p equals 0, those are x-intercepts. Okay, but this says y right here. You're right, but because this function is named p, you can actually cross out the y and you can write p. This is like the p axis right here. So wherever p equals 0, those are the x's that you're looking for. So what we found is that 0, negative 2, and 3 all give me 0. And what that means is, this is what it means. You wouldn't actually do this, but if you wanted to test it, you would take each of these numbers and you would plug them into this to see if you'd actually get 0. So you plug in 0 and you multiply everything out, simplify, add, and subtract to see if you get 0. You can test negative 2 and you can test positive 3. And all of these should equal what? 0 when you plug them in.